Hello and welcome to this Level 3 Mathematics in Context training video for Pearson Edexcel. In this video, we're looking at the product moment correlation coefficient, including its limitations. The specification reference shows that we need to recognize correlation and know that it does not indicate causation, and use and interpret the product moment correlation coefficient, recognizing its limitations. The PMCC formula is provided in the formula book as shown here, and there's quite a lot going on, so we'll break those parts down. The sigma xy is the sum of the products of the x and y values. Sigma x is the sum of the x values, and sigma y is the sum of all the y values. N, which appears 3 times, is the number of pairs of points in your data set. Sigma y squared is the square of all the y values and then added together. And sigma x squared is the sum of all of the x values squared. So square all the x values, add them up. The mapping document that maps the content of the core maths in context references to GCSE and GCE shown here. There's quite a few links and it appears in several other qualifications. So some ideas for teaching this in the maths in context approach. You could look at heights and arm spans. So there's a famous diagram by Leonardo da Vinci called Vitruvian Man. In that diagram, it suggests that the person's height is the same as their arm span. And you could look into how strong that correlation is. Or a similar one is comparing foot length to forearm length from elbow to wrist. You could, as a hands-on method, you could look at estimating mass. So collect together some things that students could hold in their hand, and then each student could hold each of those objects in turn and write down how heavy they think it is. And then you can reveal the correct masses, and students can see how strongly correlated their estimates are with the real weights. If you want to help them out with that a little bit, you could make sure that the first item is a 100-gram weight, so they've got that as a reference point to work from. Key skills for this topic are that students should be familiar with the concept of correlation, being a measure of how closely connected pairs of data are. You can think of positive correlation as one variable increases, so does the other, while negative correlation can be thought of as one variable increases, the other one's decreasing. The idea of no correlation is an important concept for those times when the data is not connected. The formula can look intimidating, so students are going to need plenty of practice substituting values into the correct places in the formula. And an awareness of the concept that correlation does not automatically imply causation is important. So if you've got a strong correlation between pairs of data, it doesn't necessarily mean that one of those is causing the other to happen. So let's take a look at an exam question. This one says, using the table, information in table 6, which I've got on the next slide, in the source booklet, and then given various summary statistics about that table. It's a Grand Prix racing statistics. The part we're looking at says, calculate the product moment correlation coefficient between the lap length, x kilometers, and the fastest lap time in 2015, t seconds, giving our answer correct to 2 decimal places. Here's the table. It's Grand Prix circuit lap length and fastest lap times for 2014 and 2015, but we're going to be using the summary statistics anyway. We do need the table to know that there are 18 countries. So we would start off by recalling the formula from the formula sheet, and it's worth bearing in mind here that we've got a formula that uses x and y, and our data is in x and t, so we can just use the x as x, that's no problem, but we're going to mentally replace the y's with t's in our calculations. So it's a good idea to break this formula down and treat the numerator separately and then the 2 brackets in the denominator separately. Other than that, it's just substituting the values into the right places. So we get this for the numerator, which, pressing the buttons carefully, gives us 136.265635 as a value for the numerator. Substituting again into the left-hand bracket in the denominator gives us this and a value of about 12. And the right-hand bracket, substituting into there, gives us a value of around 2,530. We'll use the exact values, of course, in our next step. So just replacing the numerator and then the two separate brackets with the values we just found, and not forgetting that square root sign in the denominator, gives us these numbers here. And very carefully, we're going to get a value of 0.78. So the mark scheme gives you a method mark for any of those three values, or for finding the product and the value that would be in the square root sign underneath. There's a second method for a complete, fully worked method to get the value of R, the product limit correlation coefficient, and an accuracy mark for a number between 0.77 and 0.79. The examiner's report shows us that many students were able to complete this question, although some did leave it completely blank. And a note that, generally speaking, breaking the calculation down into separate sections led often to the more successful students getting full marks, and less likely to make mistakes in them trying to type the whole thing into the calculator in one go. The follow-up part of that question says, interpret your answer to part C. You'll recall that the correlation coefficient was 0.78, and this shows a strong positive correlation. So generally, the longer a track's distance is, the more time it takes to complete it. And we could perhaps infer that that suggests the tracks are of similar difficulty. The longer the track is, the more time it takes to complete it. The mark scheme for this allows 2 marks, one for referring to the type or strength of the correlation, and then the other mark is for referring to the context. In this case, that's about distance and driving time, or perhaps the driving conditions, noting that the question is about Grand Prix driving times. The examiner's report tells us that many students were able to conclude the strength was strong and positive, and then fewer students were necessarily able to refer to this in context, and in many cases, students just didn't mention that at all, which obviously takes us into top tips for this particular reference point. So a few things. If you are given summary statistics such as sigma x squared, then there isn't any value in recalculating. There's no marks for just going through and verifying that that value is indeed correct. So just use the values that you're given. It's a good idea and good practice to write down the intermediate steps in the calculation as you go along, as I did in the example, rather than just trying to type it the entire formula into your calculator. If you do that, you're going to get the full marks if you do it correctly, but obviously there's a risk and you may lead yourself having no marks. It should give students practice of seeing questions that aren't just using the variables x and y, as that can be enough to put students off. If they've done it entirely in x and y, then being given different letters, especially if they're both different from x and y, can be enough to put students off and mean that they don't get all of the marks. And again, that reminder that the conclusion must always be in context. So one way to consider doing that is referencing that your correlation is maybe, say, strong negative correlation between whatever it is that your x value is talking about and whatever it is your y value is talking about. So remembering to refer back to the context every time. Thank you for listening to this video. I hope you found it useful.